If we are not alone, who or what else is out there? Is anybody listening? (2042 AD). Powerful orbiting telescopes scour the heavens for signs of life. They focus on a dim yellow globe. Spectrum analyzer results: negative. No oxygen, no life. The auto tracker zooms into another world, a pale blue dot. Oxygen signal affirmative, and there appears to be water. This could be it. The scenario belongs to the future, but the future is almost here. Life on Earth may have begun with a bang, when microorganisms hitching a ride on a comet or asteroid crash-landed on our planet. Finding themselves in a mild and watery world, the single-celled organisms could have slowly evolved into the rich and varied life forms that exist today. There are clues that this may have been what happened. But what do these early microorganisms look like, and from which planets or moons might they have come? Single-celled organisms are just one example of life that might exist in the depths of space. There could also be intelligent life out there, way beyond our own solar system. Some people go as far as to say that aliens have already appeared on Earth, that governments have hidden them away in secret military establishments. Today, serious efforts are being made to search for life on other worlds. Radio telescopes listen for signals transmitted from civilizations at least as advanced as ours. Seth Shostak works for SETI, the search for extraterrestrial intelligence, the offshoot of an earlier NASA program.
People in the last century thought about possibly searching for aliens using lights and stuff like that, but in fact, radio searches began in this century, and really after the war. It was 1960 that the first really scientific radio search was conducted.
Invaders from Mars.
Popular fantasies about the appearance and intentions of alien beings are as varied as human imagination. Paul Davies is a physics professor and writer of popular science. He has studied the cultural presence of aliens in human history.
When most people think about intelligent alien beings, they have something very much like ourselves in mind, that they would look like us, think like us, and behave like us, but they'd be sort of super beings. And when you look back in history, stories of angels and giants and Greek gods and so on, they're always presented in this human or semi-human form. I think that's just some sort of deep cultural need to believe in something like ourselves, but better.
From a planet.
Humanoid aliens have been good business in the 20th century. B-movie makers in particular have found a winning formula in showing semi-human space creatures with a fanatical urge to conquer Earth.
I don't think it's very likely that the Earth has been visited by intelligent aliens. In fact, the whole business of travel from one star system to another, physical travel, I think is really rather fantastic. It's much easier to send messages and communicate with your friendly aliens next door than physically get in a spacecraft and go and visit.
We don't yet have the know-how to detect them, let alone travel to them, if they exist. It's clear that only a technologically superior race could visit us. In the meantime, we strain to pick up unfamiliar radio signals and scan the heavens for clues. In almost 40 years, there have been only 4 possible messages, all of them false alarms. An alien signal heading for Earth could come from any direction. To speed up the search, a SETI program called Project Phoenix has made some choices.
Project Phoenix has a fairly straightforward philosophy. We point our telescope in the direction of nearby sun-like stars, stars that are cousins of our own sun. Those are the ones we think are most likely to have planets somewhat similar to Earth around them, and maybe with an advanced civilization on one of those planets.
No star in the search is farther away than 150 light years, and, like our sun, each one is over 3 billion years old. Plenty of time for intelligent life to have developed radio technology. The president of the SETI Institute, Frank Drake, pioneered the techniques used in the search for extraterrestrial intelligence. He doesn't rule out the idea that someone is tuned in to us.
The space around Earth is full of radio signals, and particularly television signals, which we have transmitted over roughly the last 50 years. In fact, there's a shell around the Earth, 50 light years in radius, full of our signals. And in that shell, there are about 1,500 stars which are now receiving our signals. And if anyone's there, they're able to find out all about us by watching our television.
Quick, quick, brand new, Richard Hudnut home, permanent, quick, quick, cut your winding time in half, takes half the effort, new crystal lotion does.
Can't SETI transmit powerful radio signals of its own, hoping for a response?
Some people think that Project Phoenix actually broadcasts inquiries into space and we wait for replies from the aliens. Well, we don't do that, and the reason is quite simple. Say that the nearest extraterrestrials were 100 light years away. Well, our question would take 100 years to get there, and if they deign to reply, it'll be another 100 years before their answer gets back to us. 200 years have gone by, you've probably lost interest, and surely your funding has gone away.
There may well be a communications technology that we don't know about yet, as we were unaware of radio waves only a century ago. Technology is definitely on the move. After a walk on our own moon, we began exploring new worlds by remote control using more and more advanced spacecraft. Among the most successful missions was Voyager 2. Launched in 1977, Voyager 2 explored the outer planets and their weird moons, moving ever deeper into space, into regions completely mysterious to us Earthlings. On board is a gold-coated phonograph record containing 116 images of Earth and its inhabitants, 90 minutes of music, and an audio essay of Earth sounds. The pace of technology has been so rapid that Voyager's computing capabilities are outdated, equal to just a fraction of a domestic PC. The computer subsystems on Voyager contain a total of only 33,000 words of memory storage. In 1976, the search for life and the exploration of the solar system continued with the Viking mission. Its destination, Mars. The mission, to land robot explorers on the Red Planet. On board were cameras and instruments designed to sample the Martian atmosphere and analyze the planet's dry soil for signs of life. But no life was found.
Well, as you can see
At
here,
NASA, Michael Meyer runs the administration's exobiology program, the search for life beyond Earth. For him, the Viking mission was not at all disappointing.
Viking was very successful in that it sent 2 spacecraft that landed on the surface, and part of their purpose was to measure whether or not there was life on Mars. And the experiment's very successful in that they went through, they did their measurements, and but the reactions that they found were not consistent with life.
But just because the Viking landers didn't conclusively find life on Mars doesn't mean life isn't there. It may nestle on the surface or underground. Mars, more than any other planet, has tantalized us with the notion of extraterrestrial life, intelligent or otherwise. Since Viking took the first pictures, one strange surface feature called the face on Mars has attracted much attention. Some believe it's an attempt by another civilization to contact us. The Martian craze really took off about 100 years ago. The Clark Telescope at the Lowell Observatory, Flagstaff, Arizona. This great instrument was used to produce some of the most famous drawings of the red planet. The artist was the observatory's founder, Percival Lowell. Lowell thought the aliens were trying to make the best use of available precious water supplies, building a network of canals to transfer water from the polar to the equatorial regions, a sort of planet-wide irrigation system. He wrote extensively about these ideas. A few yards from the building housing his beloved telescope, Lowell's tomb is a monument to Mars. His theories were at first embraced, then denounced. Lowell was ridiculed by the scientific world, but he never stopped believing in the Martian canals. Ironically, both the Lowell Observatory and life on Mars theories are legitimate and respected today.
He built up interest in Mars, although he was completely wrong about Mars, and everything he said about Mars practically was wrong. But he built up interest in the planet, which is carried over to this day, and so he was quite useful to the Mars exploration program.
Space exploration revealed Mars has little atmosphere and no liquid water on the surface, yet its terrain appears to have been sculpted by water. NASA geologist Ken Herkenhoff explains.
It appears that there were great oceans on Mars at some time in the past, and there's currently a debate raging as to exactly when these oceans occurred and how long they lasted, and whether there were ice sheets that float on Mars.
Today, the dry, cold Martian climate makes it inhospitable to life, but maybe not completely. An amazing survival story during the Apollo missions to our moon provided evidence that life can endure even harsher conditions. Two and a half years after the Surveyor 3 spacecraft was left on the moon, Apollo 12 astronauts returned, retrieved the lens of its TV camera, and with it, a collection of what seemed to be alien bacteria. But they turned out to be stowaways, bacteria from Earth that had traveled on Surveyor to the moon and survived there for nearly 3 years in an environment less hospitable than Mars. Here was the proof that life could endure, at least for a time, on a world other than our own. What other characteristics define life as we know it? What else should seekers of life on other moons or planets be looking for? Living things move and grow. Life needs to take in nutrients and eliminate waste. And there is one other quality that is perhaps the most important indicator of all. Oxford University biologist and author Richard Dawkins.
The most general characteristic has got to be reproduction, the property of heredity. Everything else follows from that. Once you've got anywhere in the universe heredity, the equivalent of DNA, it doesn't have to be DNA, but the equivalent of something that makes copies of itself, genes in other words, then Darwinian natural selection, evolution, and life will follow. Now, in practice, on this planet, life has all sorts of other properties like respiration and feeding and things like that. But the fundamental one is reproduction.
Today, our planet is a haven for life, a far cry from its violent beginning. The young Earth was radioactive, hot, volcanic, with no oxygen. The atmosphere was cloudy, full of noxious gases, carbon dioxide, ammonia, methane. red carpets of lava flowed over dark volcanic rock until water from the planet's interior formed the vast oceans where life first appeared. Understanding how life got going on our own planet will help us target where we look for it in space, both within the solar system and beyond. Biophysicist David Deamer studies tide pools. A tide pool has the right mix of conditions for the formation of the first simple organisms.
If we think about the kinds of key events that might have been part of the beginning of life, certainly one of them had to be a sufficiently concentrated solution. Life could not have begun in a highly dilute solution of molecules because they can't find each other. Molecules wander all over the place. The only way they can react is if they bump into one another. So this means that there must have been a concentrating mechanism. Tide pools are an obvious concentrating mechanism because as a tide pool dries out, everything in it gets more concentrated.
In his lab, Dr. Deamer wants to see how the first microorganism might have sprung up under similar conditions.
Imagine the tide has gone out and the pool is drying up and leaving behind a thin film of organic material. In this case,
simple organic material likely to have been on Earth before life began.
And the tide comes back in.
The incoming tide churns the matter together. Ultraviolet light, like the sun, adds a heat source. With the agitation and higher temperatures, something begins to happen. Some of the molecules have formed bubbles, and another kind of molecule has become trapped inside the bubbles, mimicking a cell and its nucleus. Although not actually a living thing, this simple structure mimics a single-celled organism that could have sprung up under similar conditions. Yellowstone Park. Like a reminder of early Earth, it has steaming lakes and hot mud pools that erupt at burning temperatures. A much less forgiving environment than a tide pool, yet here, against all expectations, life has taken hold. Some microorganisms are being fossilized as quickly as they form. Dr. Jack Farmer is one of NASA's exobiologists. If he can understand how simple life forms become fossilized here on Earth, space fossils may one day be easier to spot.
What I'm interested in an environment like this is how organisms are captured during the process of mineralization that occurs and turned into fossils. And the idea is that the rates at which these minerals are forming is so fast that the organisms don't even have a chance to die before they become entrapped in the minerals. And that means that you capture a lot of biological information, mostly as different types of fabrics in the rock. So this is a really excellent place to look for microbial fossil information.
The hot conditions at Yellowstone are almost like early Earth, but not quite. There's too much oxygen.
When life started on this planet, there wasn't any free oxygen in the atmosphere. There was obviously oxygen in the world, but it was bound oxygen. It wasn't free oxygen. So all the oxygen in the air has come from green plants, ultimately. When it first appeared, therefore, it would have been seen as a poison. It would have been a pollutant. But gradually, through Darwinian natural selection, living organisms have become more and more used to oxygen. They've been selected to thrive in the presence of oxygen, so that now most living organisms can't live without oxygen.
Green plants can trap the sun's energy to produce not just the oxygen we breathe, but the food that supports the entire animal kingdom. The other great life giver on Earth is water. Our water-rich world is an oasis for life. Earth's sister planet Venus may also once have had water, but soaring temperatures caused by a runaway greenhouse effect have made it a hostile environment to living things. Venus and Earth had roughly similar potential for developing into life-supporting planets, but only Earth succeeded. At Lulworth Cove in England, Ellen Stofan is trying to figure out why.
This rock is Jurassic limestone that was formed over about 100 million years ago in shallow seas. This rock is made mostly of carbonates. It has a lot of carbon dioxide in it. On Venus, most of the carbon dioxide is actually in the atmosphere. On Earth, it's tied up in limestones like these that were formed in the Jurassic. Why did Venus end up with all its carbon dioxide in the atmosphere and Earth with it tied up in big rocks like this is a question that we're puzzling with right now. We think it might have to do with something with the evolution of life on Earth. Maybe the Earth was just far enough away from the sun that it was cool enough that allowed life to evolve, took that carbon dioxide out of the atmosphere. On Venus, all the carbon dioxide remained in the atmosphere, and we ended up with a planet that's baking in its own heat.
When the sun sets, Venus is often the brightest object in the sky, outshining the night lights of Tucson, Arizona. It twinkles like a star because the planet's dense cloud cover is extremely reflective. In 1967, Venera 4 became the first space probe to penetrate the Venusian clouds and transmit data. The first probe to soft land on the surface and send back information was Venera 7 in December 1970. The Venera landers only transmitted data for about an hour before being destroyed by the planet's intense heat and pressure. In August 1990, the Magellan mission began a radar survey of Venus, which allowed imaging experts at the Jet Propulsion Lab to create this simulation of the Venusian landscape. No traces of life were found, but scientists were delighted to become more closely acquainted with our neighbor planet.
Looking at Venus through a telescope, it's magical because, it is the evening or morning star, and, seeing it as a planet itself is kind of exciting. But at the same time, since it's totally covered by a set of dense clouds, one would like to see more. And so with Magellan, we got the first chance, one of the first chances, to really get a complete map and view of it.
The Venusian landscape has a desert-like appearance, but it's a good deal hotter than any desert on Earth.
On Venus, it's about 500 degrees centigrade due to that greenhouse effect, so it's far too hot for life to exist. In fact, we think that greenhouse has existed for a very, very long time, so that even if we could get samples back from Venus, we don't think we'd find any fossil evidence of life. Here on Earth, there was abundant water, and that's where life began.
Temperatures and pressures on parts of our own ocean floor are similar to those on Venus. Not especially hospitable, in fact, downright hostile. Yet, even in these conditions where there is no oxygen, life flourishes around smoking hydrothermal vents. All over the Earth, there are amazing examples of life surviving, even thriving in harsh environments. These hardy life forms on Earth add power to the argument that life may once have existed, may still exist, in forbidding environments elsewhere in the solar system. The first humans to land on Mars may yet discover the imprint of life.
We don't know that life originated on Earth. It could have come here from elsewhere in a meteorite or comet or something. Now, from time to time, asteroids and comets hit Mars and splash Martian material around the solar system. And we know that some of this material comes to Earth because there are about a dozen meteorites that have been identified that come from Mars. One of these meteorites could have brought life here to Earth.
This is no ordinary rock. It was found on Earth, but it came from Mars, one of at least a dozen alien rocks from the Red Planet. 13,000 years ago, a rock fell to Earth. In 1984, it was found in Antarctica at a place called Allen Hills. For over a decade, this Mars meteorite stayed at NASA's Johnson Space Center. It had been mistaken for a piece of the moon. But in 1996, NASA scientists took a second look. Inside the meteorite, there appeared to be microscopic fossils, possible signs of life. The meteorite made front-page news around the world. But the initial euphoria was replaced by doubt when the evidence proved to be inconclusive.
The Allen Hills meteorite is a very important find. The things that we do know for sure is that this meteorite is very old. It's one of the oldest objects in the solar system. It had fractures that were filled with carbonates precipitated from environments perhaps not unlike this one. I mean, we think perhaps they were hydrothermal.
Even if the Allen Hills meteorite shows evidence of possible microscopic fossils, this is still not proof of life on Mars.
So really where we rest on the Allen Hills meteorite is that it's an important find but not indicative of biology.